This is a trick question. Let's get that out of the way right now. But having said that, let's pretend we haven't noticed and walk right into it. Evaluate the following limit, they say. And so we have 5x squared, I'm just recopying for now, minus 2x plus 1 over 3x plus 1. And they want the limit at infinity. The trick that we've learned for these is to find the highest power of x that exists in either of these places, which would be x to the 2, and we divide the whole works by x to the 2. So every single one of these terms we put over x squared. And let's see what we get from that. 5x squared over x squared leaves simply 5 minus 2. One of these x's is going to cancel, so we'll just be left with 2 over x. And then we get 1 over x squared. And down here we get one of the x's cancels, so we're left with 3 over x to the first power. And then we get 1 over x squared. And that's in the limit as x goes to infinity. So we have the number 5. That's good. And we know that anytime you have a number divided by an infinitely big x, that just goes to 0. So this term vanishes. We get minus 0 plus 0. Neither of those matters. And in the denominator, we get 0 plus 0. Uh-oh. This is undefined, and there's really nothing we can do to fix it. The limit is 5 over 0, which is to say the limit is undefined, which is to say the limit does not exist. So we've been saying that the horizontal asymptote is wherever this limit is. If the limit does not exist, it means you don't actually have horizontal asymptotes. You may have learned even before this course that you only get horizontal asymptotes if the power of the denominator is equal to or greater than the power of the numerator. That is true. And if you remember that, you may have noticed just glancing at this that it couldn't have horizontal asymptotes. With limits, we have another way to show it. You only get a horizontal asymptote if the denominator can keep up with or dominate the numerator, and that is not what's happening here. So this function has no horizontal asymptotes, and that would be all we'd have to do to answer this question. Because the numerator's power is 1 greater than the denominator, incidentally, this thing would have slant asymptotes, which we'll talk about later, but for now they're just saying find any horizontal asymptotes, and our answer is there are none.